Hello and welcome to lesson number 4 in Unit 1 Linear Systems in our grade 10 academic math class. This is solving linear systems of equations using substitution. So far in our journey in this unit, we've learned what a linear system is, how two lines in the coordinate plane can interact, and how to solve a linear system graphically by getting a couple graphs on there and looking at the point of intersection, which represents the solution. There are limits to that, of course, being that if you don't have the right materials to graph, or graphing can be a little bit inexact at times. We are going to now introduce the first of two algebraic methods for solving linear systems. This one is called substitution. So I'm just going to read it through right here. If you'd like to pause the video at this point, you can read it in advance. You can also write down the actual question that we're working on. I've solved it graphically here already, so we don't have to waste time with that. So maybe hit pause. Get this down so you know sort of what the target is that we're shooting for, and then we'll talk you through substitution. So do that now. Okay, you're back. So when we're talking about solving a linear system by substitution, what we're talking about is taking our two equations and substituting a value from one into an equivalent value in the other. I know that sounds confusing, but once we've done that, we've essentially eliminated one of our two variables. So you can see what we're going to be doing here is working with y equals 5x minus 2 and 2x plus y equals 5. And you can see that what we're going to be doing is we are going to take this value here that we know to be equal to y in the first equation, and we're literally going to pop it in here for this y. So we're going to have, in the place of that y, we're going to have a 5x minus 2, which we know to be equal to y if we want to be finding the solution. That's the philosophy behind it. I'm going to take you through it now, but suffice to say, when I graphed these two lines, the solution I came up with was 1, 3. And now we're going to try to arrive at the same thing algebraically. So let's start in. The first step is to sub number 1 into number 2. So I've called this first equation y equals 5x minus 2, number 1, and 2x plus y equals 5 is number 2. We're going to substitute, which is why we call it substitution, 1 into 2, and then we're going to be solving for the variable that remains. So as I said, what we're doing here is literally replacing the y in equation 2 with a known equivalent amount from the first equation, and that's going to be 5x minus 2. I'll just keep that in brackets for now just so we can sort of see it, and there's the equals 5. So everything else is literally the same. I've replaced a y with a value that we know to be equal to y, 5x minus 2. What you're noticing at this point is that we only have x's left. There are no y's. This is infinitely easier to figure out now. So let's gather together our like terms. We have 2x and 5x. That's going to be 7x minus 2 equals 5. We are going to transpose minus 2 to the other side. By adding 2 to both sides, we end up with 7x equals 7. And we isolate x by dividing both sides by 7. Giving us x equals 1. That's the first step. We've found essentially half of our solution already. We know that at the point of intersection, the x value will be equal to 1. What is the y component going to be? At this point, we are going to substitute the value that we just found, x equals 1, into 1. It could be number 2. Doesn't really matter. I think number 1's a little bit easier. And then we're going to solve for the y value. So equation number 1 was y equals 5x minus 2. So y equals 5x minus 2. We're going to substitute in for the x 1. That's the value that we actually just found. Now we have y equals 5 times 1 is just 5 minus 2, and that's going to equal 3. So our solution then is going to be 0.13. Again, that's the x and y values that we just found. Now, in order for us to know that this is correct, we need to do a check. So we are going to substitute our solution, and this is an important distinction to make. What you'll notice down here is that we substituted the x value into equation 1 to solve. When we go back to check that our solution is correct, we need to substitute into the other equation. This ensures the integrity of our check. If we just sub right back into the equation that we made a mistake in, we might make that same mistake again. So in setting up a check, we check that the left side is equal to the right side. So I've written the left side of the equation as 2x plus y. So that will be 2 times 1 plus 3. That's 2 plus 3, and that's going to equal 5. The right side of the equation is the same, so we want to say, therefore, left side equals right side. And I always like to put a little happy face on there because we did it. We did a good job. And now we are going to sum up our findings with a therefore statement. So therefore, the solution, or point of intersection if you prefer, the solution is 1, 3. Also important, get the brackets on there, get the comma in there. You can't just write like 1 and 3. That kind of looks like 13. There's no context. It doesn't make any sense. It's got to be an ordered pair. And that is how you solve by substitution. Again, just to recap that, I'm substituting a known value from one of the equations into the other with the purpose of eliminating one of the variables. Once I have one variable only in my equation, I solve for that variable, take that answer, substitute it into one of the two equations to find the component of it, the complementary component, the y or the x. Then you do a check, and then you do a therefore statement. Let's do it a few times here. Here we have our first one. We have 3x minus 2y equals -5 and x minus y equals -2. So one of these is going to be a little bit easier to organize. I'm going to definitely nominate number 2 as the one that's easier to reorganize. The reason being that you'll notice the coefficient in front of the x is 1 and the coefficient in front of the y is also 1. This makes it easier for us to isolate one of those variables. So I'm going to manipulate 2 and I'm going to turn it into a new number 3. What I'm going to do is transpose the negative y over to the other side by adding y to both sides. So I'm going to have x is equal to -2 minus y. And, -2 plus y, I should say. And that becomes my equation number 3. So step number 1 then becomes, we are going to substitute 3 into 1. Again, the reason I'm doing this is because we have 3x minus 2y equals -5. There's two variables in there, x and y, that doesn't help us. However, once we substitute a known value for x into that first equation, then we are only going to have y's left, which is really nice for us. So let's do that substitution now. We have 3 bracket, and this is where I substitute in the value that I know to be equal to x, which is right here, -2 plus y. And then we have the -2y. This is just from the original equation, and there you go. So now, unlike last time, we have a little bit of math to do here before we get to the solving. What we need to do is distribute the 3 into both terms in this binomial here. So we have 3 times -2, which is -6, plus 3y minus 2y equals -5. Let's simplify this. -6 is still going to hang out here, but if we have plus 3y and minus 2y, that's going to be plus 1y, or just plus y. There's our -5. We are going to transpose this -6 over to the other side by adding 6 to both sides. We then have y equal to -5 plus 6 is going to be a plus 1. So we're halfway to our solution. In order now to get the last one, we are going to substitute y equals 1 into one of these two equations. So let's have a little look up here and see which one looks easiest. I definitely think the second equation looks easiest. There's just a single solitary y hanging around there. So let's do equation number 2. So that will be x minus y equals, what was it, -2. X minus y equals -2. Now we're going to substitute in that value that we know. We know y to be equal to 1. It's -2. Let's transpose -1 to the other side by adding 1 to both sides. We then have x equal to -2 plus 1 gives us -1. So we think that our solution, let me just check our spacing here. Oh, I got lots of space. So we think that our solution at this point is going to be -1 for the x and 1 for the y. But we need to do a check first. Now you'll notice that we used equation number 2 to come up with our x value. We're going to be checking using number 1. We just can't use the same one there. Or the same equation rather. So equation number 1 is 3x minus 2y, so that's left side. 3x minus 2y, and then we have our right side, which was -5. There we go. All right, now we're going to substitute in. So our x value we believe to be -1. Our y value we believe to be 1. And that gives us -3 minus 2. That's going to give us -5. And as you can see, the left side equals the right side. So therefore, left side equals right side. Pop a little happy face on there. That's the good times. And now we sum it all up with a therefore statement. So therefore, the solution is -1 and 1. And there you have it. That is substitution. I'm going to pause here. We'll do one more example, and then we're going to do a word problem, and then you'll be off to give this a try on your own. So I'll see you in part 2 of this video.